Who's here in recovery mode from last night? Okay, that's not the only one. Okay, so I'm gonna be talking. I'm talking about a lot of stuff real fast. So everyone, just bear with me. Mainly, I'm gonna be talking about how to embed your own scripting language. Well, maybe not your own. If you do decide to build your own, you could embed it. But other third-party and officially Microsoft-supported scripting languages into C# payloads in order to sort of shift back the paradigm back to like PowerShell style like attacks, right? Because with the whole migration to C#, the red team community, if you're not familiar, has been sort of migrating its tooling over to C# for the last 2 years or so, but fairly recent. And while that's great, and there are reasons for doing that, which I'll be explaining too, like it would be great if I didn't have to compile stuff all the time, like server side, client side, like that's the beauty of using a dynamic language and a scripting language, is that you don't have to compile stuff at all. You just throw it at the endpoint and you're good to go. So this is like my approach of sort of solving that operational problem, because compiling stuff, I personally hate it. Especially on time-limited engagements, like it takes a lot of time, especially if you haven't set up your like continuous integration pipelines and stuff. So, so this is my approach on that. This is the obligatory "Who am I" slide. My name is Marcello. I go by Bytebleeder on the Tweety Twitters. I work for Black Hills InfoSec. I've written a bunch of stuff over the course of the years, which you can find at that GitHub link if you're interested. I mainly do just open source dev and red teaming at Black Hills. So this is the agenda we're going to be going over today. We're going to be covering some of the key motivations. I'm going to be talking about some basic .NET framework concepts just to get everyone on the same page, because in order to understand what I'm going to be talking about, and if you're not familiar, if you're not a .NET developer, you're going to need to understand at least some basic concepts. Then we're going to be covering like how to embed these scripting engines, and some pros and cons to each language that I've tried so far. And then I'm going to be hopefully demoing. Everyone start praying to the demo gods right now. Some payload BYOI payload examples, which is bring your own interpreter payloads, which is what I've started calling this class of payloads. After that, we're going to be demoing Silent Trinity. I'm going to be demoing Silent Trinity. And that's sort of my C2 framework, which I've been building for the last year or so now. That sort of tries to wrap it and put a nice little ribbon on like some of these concepts that I've been researching for the past year or so. And then we're going to be covering detection, which is hard, but it's getting better and better. So that's a good thing. And then questions and answers. So like I said, when I first opened up, like the key motivation behind this really was just to like shift the paradigm back to PowerShell style-like attacks. And at the time, I really didn't know anything about .NET. I didn't know anything about C#. I didn't even know how to code with C#. I just knew it existed. It was a thing. I did do some PowerShell stuff though, so I was coming from a fairly good spot. And the main issue, again, like the main issue I had with all the C# tooling was that it's a compiled language. It's not as flexible. It really does take a lot more time to do stuff on a red team engagement. And I really like scripting languages. I also like developing weird stuff. So when a concept comes out, like when a new red teaming technique is discovered, I like to take it and sort of like get weird with it and see what else you can do. And again, yeah, it's just to shift the paradigm back to PowerShell-like attacks with all the flexibility that scripting languages give you. So. And this is where we're going to have to start covering some basic .NET concepts, because in order to understand why this is even possible in the first place, you need to understand some basic concepts. I won't get too in the weeds with this, because I know it can get a little boring, especially if you're not interested at all in like .NET development and all that stuff. So, but like the .NET assembly, this is a fundamental thing that you need to know in order to understand what I'm going to be talking about. .NET assembly is just a single unit of execution that can be interpreted and executed in any .NET language. Okay, so that has very interesting implications, by the way. But all you really need to know is that it can be interpreted and executed in any .NET language. Okay, and if you're not familiar with C# development or any .NET development whatsoever, that's another important thing, by the way. A lot of people associate C# with .NET. Like when they hear .NET, they automatically think C#. That's definitely not the case. .NET Framework is literally just a set of tools that Microsoft gives you in order to build your own programming language. So it's like tools and infrastructure that you can use to build your own programming language. It's not necessarily tied to C#. It's just basically just a literal framework that you can use, and it makes things a lot easier to build a programming language. I don't know if you are really interested in .NET development, the more you start researching this stuff, the more you start realizing this is like sort of a marvel of engineering. Like the .NET framework is amazing. I'm not gonna lie. And so if you're coming from like unmanaged languages like C++, so in .NET we use managed and unmanaged to define managed .NET languages or anything that basically is tied to .NET and the CLR. If you're coming from like C or C++ development, it's also important for you to know that a .NET assembly is what you get from just compiling any .NET language, in this case C#, to an executable, okay? So you take your C# code, you compile it with Visual Studio or MS Build or whatever, and you get a .NET assembly, right? But what's probably a little bit different from what you'd expect is that if you compile that same code to a DLL, that's also a .NET assembly. And this is where things start getting a little bit different from what you'd expect from like a compiled, from a unmanaged language. And another also important thing to know is, I'm going to keep saying that, and also I apologize if I keep saying .NET and framework all the time, but in a talk like this, it's kind of almost impossible to avoid saying that. So in a .NET assembly is not the same format as a native executable in DLL, okay? So just because it has a .exe or DLL at the end of it as an extension, it's a completely different format. I could do it could be a whole nother talk talking about like the format of a .NET assembly, because that in itself is a hell of a rabbit hole to go on there. But this is a very important distinction to know about. So there are a lot of .NET languages, okay? Because like I said, .NET is just a set of infrastructure and tools that Microsoft gives you in order to build your own, okay? So there are a bunch of natively supported .NET languages, and there are also a bunch of third-party .NET languages, okay? So on the screen here, I got C#, PowerShell. PowerShell, if you didn't know, is a .NET language. F#, these are sort of, and there's a bunch of others too, like VB.NET and mixed mode assemblies, which is, that is just a nightmare. But basically, these are like the main three .NET languages that Microsoft officially supports. But because it's a set of tools and infrastructure that you can use to build your own languages, there are a bunch of third-party .NET languages as well, like IronPython, for example. So IronPython is nothing more than a Python implementation on top of the .NET framework, okay? So CPython, normal Python, right, is built on CPython, which is built on C. IronPython is built on the .NET framework, okay? So it's a completely different, two completely different beasts. There's also Boolang. So how many of you heard of Boolang before? Okay, well, you guys don't count. Boolang, so there's Boolang, which is also another .NET language, and I'm gonna be ranting and raving a lot about Boolang because it's amazing. And then IronRuby. If you want to build your post-exploitation scripts in Ruby for some reason to interact with .NET, you can totally do it with IronRuby. There's a bunch of others. I actually have a list at the end of the slide deck of all of the third-party .NET languages that I've found so far, and I keep finding now one like every other day now. It's kind of ridiculous. But yeah, there are a bunch of third-party and officially supported Microsoft .NET languages, and this is where we sort of like start tying all this stuff together, right? So remember when I said before the .NET assembly, single unit of execution that any .NET framework can, any .NET language can interpret and execute. What that also means is that these languages, so because of that, these languages are all interoperable with each other, okay? So what this means is that the .NET framework is basically the underlying thing that ties all of these languages together. So if you can do it in IronPython, you can do it in PowerShell. If you can do it in PowerShell, you can do it in IronRuby, so on and so forth. And they all have native access to .NET APIs. So the reason why PowerShell, like for attackers and defenders and sysadmins, is so great because .NET framework, tightly integrated with the Windows operating system. From an offensive perspective, you can do the same thing in PowerShell in IronPython or Boolang or IronRuby. So this is why I think this is a very interesting topic personally, just because like you can do everything that you can do with C#, for example, only in a scripting language without having all of the overhead of setting up a development environment and that kind of thing. So this really is the meat of the talk, okay? And again, like from a tradecraft and operational perspective, the reason why C# was chosen as like the jumping ground for basically taking all the offensive PowerShell stuff and moving it over to C# was because if you're a PowerShell developer, you'll find yourself somewhat at home in C#, and also because of the reflective capabilities of C# and any .NET language, really. And all of the tradecraft so far really comes down to this single little function that we use on basically any red teaming engagement and all the tools that we use. Assembly.Load. Assembly.Load is magical because this thing, you throw it a byte array of a .NET assembly, right? And it'll just completely just take it and say, yeah, that's great. I'll load it into memory, and now all of a sudden you have access to all of the code that you wrote in your .NET assembly. And remember what I said before, right? How do you get a .NET assembly? You just compile your C# code into a DLL and executable, okay? So what that means is, go deeper. That's what it means. No, never mind. So what that means is that we can basically take any .NET assembly, throw it at assembly.load, and it'll just load it for us. And what that means is basically we have native reflective DLL and executable capabilities, reflective injection DLL and executable capabilities in a language by default. So that's kind of crazy, and that's why C# and .NET languages from an operational perspective are so sought after, I guess, for lack of a better term, because of this built-in functionality that allows you to basically just do reflective DLL injection and reflective PE injection into the language, okay? And again, like another reason why we transitioned from PowerShell to C# is because as of very recently, all of the PowerShell defenses were built into the runtime, the PowerShell runtime itself, right? They weren't built into the underlying .NET framework. So what that means is that all you have to do to get around all of the issues with AMSI and script log logging, transcription logging, and module level logging and all that stuff, all you really need to do is just jump to another .NET language, right? Because once you jump to another .NET language, you won't have any of those protections built in. Now, Microsoft actually has released .NET 4.8 recently. .NET 4.8 has built-in AMSI support, okay? So what that means is that some of the C# tradecraft that we've been using so far is probably not going to be as effective as it was before. However, I have found that the actual update to get .NET 4.8 won't actually, it'll basically .NET 4.8, you only get .NET 4.8 if you download a new image from Microsoft.com as of right now. I've found that it's really hard to actually get that update on previous Windows 10 builds, but I might be wrong. In fact, someone please correct me on this, but just from my experience. So basically, we can bypass all of the PowerShell protections, all of that stuff, just by jumping to another .NET language, okay? And so far, the red teaming community has jumped to C#. But the meat of this talk is what happens if we jump to IronPython, Boolang, IronRuby, right? So we can basically do everything that we can do in C# only in a scripting language and not have to compile stuff all the time. And this is what led me down this entire rabbit hole of trying to embed different interpreters and different engines into .NET languages, okay? And yeah, this is gonna be weird. It's gonna be really weird. So we're gonna make some weird shit right now. Yeah. So believe it or not, you've been doing a form of what I'm going to be talking about, whether you knew it or not, and tools like NPS, Powerline, or in PwnShell, like all of these tools basically took the PowerShell runtime, right, and embedded it in C#. So as a red teamer and a pen tester, you've probably done this more than once already without even knowing. So the only thing, so it's not what I'm talking about, it really isn't a novel concept. The only thing somewhat new about what I'm talking about is that, well, instead of PowerShell, what happens if you just embed IronPython in it, right? That's what I'm talking about. And from an OPSEC perspective, this also has the downside of, especially like, you can take C# code and also embed it in PowerShell, by the way. So like, you can do the reverse as well. And if you do that, though, if you don't mess around with like emit APIs and all that stuff, which is basically just writing code without actually writing code. It's a really weird feature of .NET. It'll basically drop stuff to this. So if you embed C# in PowerShell and call add type, it'll automatically compile that on the fly. But there's an OPSEC, I guess, con, which basically drops that file to disk. So that's sort of a thing that you should keep in mind as well if you do decide to embed C# in PowerShell. So there are some common problems / patterns that you'll run into when embedding this stuff. The main issue is that obviously it's a third-party language, so the DLL, the .NET assemblies required to actually get the compiler or interpreter, whatever the programming language calls it, running. Those DLLs are not built into Windows, obviously, right? So that's a problem we're going to need to solve. And also, you are going to need to actually resolve those at runtime. So like when you start up your PowerShell script that embeds the Boolang compiler, you're going to somehow need to resolve those DLLs at runtime to tell PowerShell, hey, you know, the DLLs that you need are here, right? And there are ways of doing that. I'm not going to go real deep into this because, again, like I don't want to bore you with just like .NET development. But the main way of doing it is calling assembly. If you're in PowerShell, it's just calling Assembly.Load in PowerShell. And again, that's because PowerShell can interact with the .NET framework. You can do the same thing as C# does and vice versa. If you're in C#, you're going to want to hook the app domain assembly resolve event because the main reason for doing this event basically allows C# to know where to go get these assemblies, essentially. So you can put any logic of yours in that event, and now all of a sudden when you execute your C# payload and C# tries to resolve those assemblies, it'll just execute your logic. So you can say, hey, if you don't find these DLLs on disk or in your current directory, go download from the internet, from my server, for example, right? So it's a really powerful feature. So the first thing that we're going to look at, and the first one that I took a look at, is IronPython. And this is what started this whole rabbit hole. So IronPython 2, again, it's a Python implementation top of .NET framework. The only problem with IronPython is it doesn't really, it supports pinvoke. So pinvoke basically is what allows you to interop with native Windows API calls. So, and from an attacker's perspective, this is awesome because it allows us to inject shellcode, allows us to do all of this stuff that we do on almost every engagement, right? Inject Mimikatz in memory, all that kind of stuff, right? So the problem with IronPython, though, is that it does support pinvoke, but when you try to do pinvoke in a embedded IronPython engine in memory, that module breaks. So if you're running IronPython in memory and try to do pinvoke, it just throws up on you. Like it just decides not to work anymore. And so that was a big issue. And I'm sort of a Python guy, and I was really sad when I first ran into this problem. I actually found like 3 or 4 bugs in IronPython, as in like bugs, not like security vulnerabilities, just by developing this kind of stuff. So yeah, IronPython is definitely like, it's not as streamlined as you'd expect. So all of these code samples are hosted, that I'm about to show you, are hosted on that Git repo. So if you want to follow along or look at it later, definitely go ahead. So the one that I'm going to be showing you is invoke IronPython.ps1. So this is embedding the IronPython compiler within PowerShell and executing Python through that, okay? On that repo, though, there's also sharpsnake, which I thought was cute, that basically embeds the IronPython compiler within a C# binary, okay? And IronPython requires 4 .NET assemblies to run, 2 of which are from Microsoft. They're not signed, unfortunately. There's Microsoft Scripting and Microsoft Dynamic. These 2 are used by IronPython to access the DLR, which is basically a feature in .NET that allows you to actually build scripting languages. And then IronPython and IronPython modules give you access to the IronPython runtime and modules respectively, right? So let's start praying to the demo gods here. I have my VM. There really isn't a lot that could go wrong, but now I probably jinxed it. So I have my IronPython script here. So this is a PowerShell script, right? Can you see that? Is it font too small, too big? Okay, sweet. I have a PowerShell script here. And what we're doing is we're importing just the print function, but we're also, take a look at this, we're also importing system.net. So we have access to the CLR, right, to all of the Windows .NET APIs in Python itself. This is just a really simple example just to give you, and just to make you understand. But and then we're printing hello from IronPython. These are the 4 DLLs that I was talking about. These are the 4 .NET assemblies that allow you to actually spin up the IronPython compiler. This is the function that loads those assemblies, right? and that there's just some cruft there that just makes everything a little bit nicer. And then this is where the magic happens. So once we load those assemblies, and we now have access to IronPython hosting that Python create engine. So this is what actually spins up the Python engine. And then we can set variables in the engine itself. So we can actually set like global variables directly inside the IronPython engine. And then after that, we're just executing the embedded script. Okay. So if I do load this up, and there you go, beginning of the file. See, I jinxed it. I knew it. Let's try that. Let's try to go with this. Actually, here, on the fly coding. Let's see if I do this. Import system. And then what we're going to do here is we're just going to do line hello from IronPython. And this is not going to .NET. There you go. Or maybe not. Console is not defined. Well, that's great. Okay, well, yeah, see, I jinxed it. The next one will work, though. I tried it. But yeah, so this is very interesting. But the one on the GitHub repo works, so trust me on that one. But this is very interesting for a number of reasons. One is that if you do embed these languages in PowerShell, what happens is that the PowerShell protections really, like all of the AMSI stuff, really doesn't have any insight into the actual Python code that you're executing, okay? And that's because once you embed the engine and actually throw source code at it, like the AMSI and all this script block logging, transcription logging doesn't have any insight into the IronPython code because it's just a layer deeper, right? It's like making that transition automatically to another .NET language. So all of those protections go away. And I think we have a question over there. Yes, that would probably work. Yes, we could try that. You're not wrong. From system import. Hey, fixed it. Thank you, random citizen. Thank you. No, appreciate it. Thank you. It's hard to code and present at the same time. So there you go. So that works, and we got our little that I just closed. Fantastic. But you saw it. It executed, and we got it. It was fine. It was all good. Okay. So that's IronPython. Like I said, it's not from this is the one that I initially started with, and it's not that. From a tradecraft perspective, it's great, but because of the p-invoke issue that I talked about, it's not that great for operational tradecraft. So Boolang, and this is where stuff gets interesting, okay? So Boolang, if you haven't checked it out, you should, because the wiki, by the way, is amazing. Originally, it was built, I just found this out at DEF CON, actually. Someone actually came up and actually told me the reason why Boolang was created, and that's because it was built for the Unity engine, so for the Unity game engine. Originally, it was built for that so that you can script within the Unity game engine. I had no clue. I just used it for malware all this time. But that's apparently the original purpose of it. And it's sort of like a love child between Python and C#. So if you're familiar with Python, you'll be at home. And if you're familiar with C#, you'll be at home because it's got some of the constructs of both languages. It's heavily inspired by Python. And the great thing about Boolang, though, is that you can call native functions. So you can do p-invoke. So in this 16-line script here, this is just calling the mini-dump write-dump API, right? And just dumping LSASS to disk in 16 lines of Boolang code, which I think is awesome. And because these languages come with their built-in compilers, say you didn't even want to embed all this stuff, do any of that, it's like Marcellus is too hard, screw it. What you can do is you can download the language. These languages usually come with their own compilers. So what this means is that you can take this 16-line script right here, compile it, and you'll get an executable that will work on just any Windows environment. So I think that's really cool, just because it gets around the whole issue of setting up a development environment, no Visual Studio, you don't have to futz about with the the UI if you're not familiar with it. It's just Sublime Text, compiler, done. That's it. And now you can just run it wherever you want. This is the main advantage of doing it this way, I think, right? So again, like this code, which will work this time. Oh boy. Offensive DLR, it's hosted there. There's runboo.cs, which is embedding Boolang in C#, and then there's invoke jump scare, which embeds Boolang within PowerShell, which is the one I'm going to be showing you here. It requires 3 .NET assemblies to run, which is even better than IronPython, right? And also, it compiles straight to memory. So as opposed to like embedding C# in PowerShell, where there are going to be artifacts left to disk if you do decide to compile it, Boolang, the compile to memory flag actually compiles to memory. Like there is no artifact left on disk, which is great. So I'm going to be demoing this to you. So this is invoke jump scare. I had to change it to invoke Boolang because AMSI. So once you change it to invoke Boolang, you're good to go. But this is a proof of concept that will execute shellcode using a embedded Boolang script and compiler. Okay, so this is just over here. So this is the shellcode. You can actually put this in the Boolang source itself instead of in PowerShell, which is probably stealthier. But just for demonstration purposes, I put it there. The real magic happens here, where you're starting up the Boolang compiler. You're throwing it the Boolang source code, and then you're executing the main function in Boolang. If we take a look at the actual Boolang code here, which do you know what? I'm going to pull this up in Visual Code because like this I can actually zoom in for you. That's great. That's always good. Pass through. Derbycon. Here you go. Shellcode. All right, 1 second. I have to press multiple keys. I have to put the mic down. Okay. Sweet. So is that good? All right. So this is the Boolang that executes shellcode, okay? And I ported over a couple of shellcode injection techniques. So these are all the DLL imports. So as you can see, like it supports pinvoke, which is great. These are the actual logic to actually execute. This is the QUAPC method of injecting shellcode. This is just using wait for single object. And this is just inject remote, which is the standard create remote thread shellcode injection technique, okay? So I sort of, in the repo, I took the Boolang source code and put it in its own file, but you can actually put it in the PowerShell script and just like execute it on the fly. So if we do this, which, nope, wrong one. Okay, so now, I'll put the mic down, hold on. There we go. We got calc. So, thank you. So that's really cool for a number of reasons. But again, like the best part about this is that there are actually no artifacts to disk when you do this, right? And again, like you can take that shellcode Boolang script and compile it. If you don't want to embed it, you can just compile it to its own executable and just run it if you want. Like it works wherever you want. And again, because like these languages are interoperable, you can just keep embedding these languages within each other too. So like if you want to get crazy for say like you're drunk at 6 a.m. and decide to, yeah, I'm just gonna embed like all of the compilers. Let's see what happens. You can embed, I've actually done this. You can embed IronPython within Boolang, within PowerShell, within C#, and just keep on going. Like it just works. Like it's amazing. I just find this really, really fun. So ClearScript, this is a recent discovery of mine. So ClearScript is a official Microsoft project that is basically designed to give scripting capabilities to your C# executables, okay? And it has its own JScript implementation, from what I understand. So this is where I actually sort of need your help because I'm not, I can't find the COM calls necessary to actually initialize the Windows script host environment and all that stuff. So I think it uses its own JScript implementation. I just can't verify that because the way it's written is really awkward and I can't seem to find like all of those COM calls necessary for it to do that. But from my research, it does seem like it doesn't go through the Windows script host environment. You can also you can also use VBScript with ClearScript. Okay, that's not confusing at all. And also, as of ClearScript 5, it also supports the open source JavaScript engine, V8 High Performance, which is also really cool. But just note, if you do decide to use that for some reason, you actually do need like additional DLLs, which is kind of a pain. But what's really interesting though, because since you can use JScript, what this means is that you can use all of those fun functions that JScript gives you, like ActiveX object, like get object, like all of those stuff that allows you to like download SCT files from the internet. And all like subt's work, if you're familiar with it, like the SCT files and basically anything that JScript that he put out, you can use it within ClearScript. So this is an example of embedding ClearScript within C# and PowerShell, and we're calling the ActiveX object wscript.shell, and we're just executing calc, right? So what I'm going to be demonstrating here is invoke ClearScript.ps1, and I'm using PowerShell because it's just easier than compiling stuff like live, which is probably not a good idea. But you can use VBScript if you want, and this embeds ClearScript within PowerShell, right? And then we're calling getObject on a SCT file hosted on my laptop. So we're going to be basically like downloading the SCT file and executing it through PowerShell within ClearScript. Yes. And again, if you want the high performance V8 JavaScript engine for some reason, you're going to need 3 or 4 more DLLs. But yeah, let's take a look at that. So get that out of the way. Invoke ClearScript. So there you go. So this is, again, like this is awesome because ClearScript only needs 1 assembly. So that's even better. So we're just embedding the assembly within PowerShell. We're calling Assembly.Load on it. We're then initializing the JScript engine. Microsoft ClearScript Windows JScript engine. So this tells ClearScript, hey, I want to code in JScript. But you can also do stuff in VBScript as well if you want. So, okay, so this is the best part about this whole thing. Because of how ClearScript works, you can expose the .NET CLR to ClearScript's JScript implementation. I know it sounds awful, but that is how I think the best way of describing it. But so what you can do is basically just import .NET APIs. So here we're importing system core, system reflection, system runtime, interop services within JScript itself, which is kind of crazy. And, whoa, that was weird. Okay, don't do that again. Oh, no, it's doing it again. Okay, don't do it again. So now we can call getObject and also have access to the CLR all in one place. And so now what I'm going to do is I'm going to go back to here real quick. And this is just starting up a Python HTTP server, so it's not really anything. One second. Okay. All right, so we got our HTTP server up and running now. So now we're going to execute this. It's going to download the SCT file and execute calc, hopefully. There you go. And again, like notice that we're able to call .NET APIs through JScript as well, because I basically called console.writeLine through ClearScript itself. My slides. There you go. Okay, so those are by far the 3 most interesting ones that I've played around with so far. This, on the other hand, though, is a list of basically all of the other interesting ones that I definitely would love to take a look at if I ever had the time. There are Lua implementations on .NET for whatever reason. There's a bunch of JavaScript implementations, which is interesting. I keep saying this. I've yet to find the time to do it. But I would be interesting to see if you embedded JavaScript within C# and threw it a beef hook. That would be interesting. I think it would break because it's not a browser, but the idea of beefing endpoints is kind of hilarious, and I kind of want to try it. By far, though, the WebAssembly one. Now, this shit is crazy. So The WebAssembly.NET implementation allows you to execute and create web assemblies within memory within .NET. Think about that for a second. Now that's just crazy. So there's probably some really interesting shenanigans you can pull with this, especially for like tradecraft and stuff. You can probably like host web assemblies that actually are web pages, which also contain payloads, and then just grab it from a website and execute it there. There's probably a bunch of opportunities here for some shenanigans. So I have to definitely take a look at it when I have the time. But yeah, these are probably the most interesting ones that I've found so far. But there's IronPython 2. IronPython 3 is in the works. I doubt it'll be ready by the EOL next year of Python 2, but you know, there's always a possibility that it is. But by far from like pure operational tradecraft perspective and utility and all that stuff, Boolang reigns supreme as it is right now. Boolang is by far the best one that I found so far. And it was developed by one guy, and it's not getting any love. So you should all create malware with it to show some love to the developer. So like I said before, like you can take, because these languages come with their built-in compilers, because again, like the .NET framework isn't a language. It's a set of tools and infrastructure that allows you to build your own language. And it also allows you to build your own compilers really, really easily. Like, I mean, like not from scratch, which is great. So you can basically take all of these code snippets that I have on that repo that I showed you, offensive DLR repo, and you can compile them. If they're Boolang script, you can compile them with the Boolang compiler, and then you can just drop them on systems and it'll just work. The great thing about compiling it is because, from what I understand, because Boolang compiles the source code to MSIL directly, it'll even work on older versions of .NET. So it'll work on .NET 2.0. So you can take these compiled Boolang scripts and put it on a Windows 7 machine or old versions of anything with .NET, and it'll just work. It's fantastic. And this is definitely like the easiest way of weaponizing anything. Like if you don't want to deal with the embedding, this is probably the easiest way to weaponize anything, right? So because of the flexibility that this provides you, right, I thought, well, let's write a C2 tool, which was a bad idea because writing C2 tools takes a lot of time and it is hard. But I did it anyway because I hate myself. So Silent Trinity is, you can get it at that link there, is basically a C2 tool that I developed, and it's got a bunch of updates recently. I'm actually going to be demoing to you the latest update, which I've yet to release. I'm going to be releasing it after this talk. Essentially, it allows you to take advantage of this. So the original version used IronPython as the main embedded language to do all of its stuff, right? I recently switched it over to Boolang because Boolang is by far like, it's 100% better than IronPython in every way, shape, or form, okay? So I'm going to be demoing Silent Trinity to you. One thing I want to point out real quick is, like, again, the whole point of this is like shifting back to paradigm to PowerShell style, go away, PowerShell style like attacks. So if you take a look at the Silent Trinity modules, you will see, like this is the Mimikatz module in Silent Trinity, you'll see that it is source code, right? Which is amazing. So what that means is that now you can, without compiling anything, server side, because all the compilation and interpretation happens on the endpoint, you can edit these real time, like on your server, and then every time you run the module again, those edits will just, because it's source code, right? They'll just get thrown down to the endpoint and compiled on the endpoint automatically. So, and this is the Mimikatz module. It's shorter because I'm doing some weird, I haven't found the time to rewrite the Mimikatz PE loader in Boolang. So what I'm doing is I'm cheating a bit. And I'm basically, I stripped down Sharpsploit, took its PE loading functionality, compiled that to a C# assembly, embedded that within the Boolang source code, and executed that through the C# assembly, which, yeah, but it works. So, hey, whatever. But I think there's a friend of mine who's actually writing a Boolang port of that. So because especially with .NET 4.8, since Sharpsploit is not going to be detected every time because it's got AMSI, once we port that over to Boolang, this technically should just go through AMSI and all that stuff because, again, it's going a level deeper. There really isn't any insight into this. And so it's, again, like shifting, sort of trying to shift back the paradigm to PowerShell style like attacks, okay? So if you never used Silent Trinity before, the new update, the old new update, but the old new update, I basically changed the whole thing to a team server. So it's like a client server functionality similar to Cobalt Strike. So there's a team server, you start that up. Well, that's the client, hold on. Let me start the actual team server up. This is going to look awful because the font is large, but I promise you, once you scale it down, it actually looks pretty. And once you start the team server up, we're good. Always check the certificate fingerprint, for God's sake, because otherwise, something could be man in the middling to you. But once you do that, you can connect to it with WebSockets. So the whole thing uses WebSockets. So what that means is that there's real-time communication between the team server and the client. The team server, it supports multiple users, so it's multiplayer, and the client supports multiple servers. So it's multiplayer, multi-server. You can manage multiple servers and multiple clients from a single instance. So once you connect to it, I passed in an RC file. So if you're familiar with Metasploit resource files, basically it'll just run every command that you have one by line in there. So I passed it that. I told it to start up the HTTP server, the HTTP listener, rather, set the bind IP and the port. This is going to be really awkward because now I have to do this because I actually want to explain stuff to you. But OK, I'll figure it out, I guess. So it's got some fancy autocomplete stuff, which is really cool. I think this is probably like the coolest thing about this, is that it's got some fancy autocomplete stuff here. So it'll tell you like all of the available commands. It's also got a help menu, which is good. So it'll tell you all of the available commands. The documentation currently is lacking on GitHub. So navigating the client probably help, and every command actually supports a -h option. So it's sort of, I hate to use this, but it's self-documenting. But list.h, it'll give you all of the options that the command supports, and so it's pretty easy. If you ever used Empire or Metasploit, you'll find yourself at home. Okay. So there's the concept of stagers. So stagers are nothing more. So we have a listener running, right? We actually need to execute something. Stagers are nothing more than some .NET scripting language embedded in another .NET scripting language. That's essentially what it is. So using the PowerShell stager sort of defeats the purpose of this tool, but it's there for convenience sake. And also, like, I've gotten a lot of angry emails saying, please, for the love of God, get a PowerShell stager. So I decided to add it in, but again, like, it sort of defeats the purpose of using this tool in the first place, but I guess for convenience sake, it does make sense, right? And I'm gonna be using this during this demo, but there's also an MS build. Oh, I'll be showing you this too. There's the MS build XML stager. So if, again, subt's work, which basically embeds a C# script within an XML document, and it sort of is still a whitelisting bypass. And there's a bunch of others coming too. I don't think I'll release all of them, but there's definitely a bunch of others coming. There's also just a C# source file, so if you want to just compile it with csc.exe, you can do that as well. So generating a stage is pretty easy. All you have to do is use PowerShell. Yeah, so the stagest one is the one that I'm not going to release just because I still haven't figured out all the kinks in it, but also because I kind of want to use it before I actually burn it. I still haven't actually had the time to actually use this on an engagement yet, at least the stageless PowerShell stager, so I kind of want to use it before I burn it completely. But once you select the PowerShell stager, the Avery stager has a bunch of options to it, but then once you select the PowerShell stager, you just hit generate, and then you give it the name of the listener, and it'll automatically do everything for you. So generate HTTP. We now have a stager. The server streams it down to the client, and then the client saves it to disk. So I already transferred that to my VM here, which if I can pull up, that'd be great. There you go. So let's pull this up. I'm going to be running this as admin, just because I want to show you the Mimikatz one. Is the font okay? Okay. Yeah, I'm going to do that, and hold on. Forgot to do this earlier. Okay. So I'm going to just copy this real quick. So what I'm doing here is I'm going to be executing two stagers, the MS build one and the PowerShell one, okay? And I'm going to use the admin on both, but I'm going to be executing the MS build one from the command prompt because Defender just flags on anything that touches AMSI from that touches LSASS from PowerShell now. Like like the stager works and everything, but the behavior of it, like it seems like anything that touches LSASS from PowerShell just flags it. Like it doesn't matter what the hell it is. I think it's mostly, you know, it's our fault, but I think that's basically what I've found during this. So I'm executing the XML stager, and from here I'm going to execute the PowerShell stager. If I can type, I should learn how to type one of these days, considering my job. PS1. There you go. Okay, so there you go. Okay, sweet. So it did a lot of things under the hood here. So this is a PowerShell stager that embeds the Boolang interpreter, right, through a C# assembly. Okay, so it's basically embedding the Boolang interpreter in the C# assembly, and the C# assembly is in PowerShell, and it's loading it that way. Okay, so you give it a URL, and it'll download all the DLLs necessary and stuff, and now you have an agent. Okay. So what I'm going to do here is I'm just going to show you, because I have 5 minutes left apparently, I'm going to show you the newest feature of Silent Trinity. It's got uploads and downloads, right? Okay, you think that's whatever. But it allows you to do really cool stuff now. So what I'm going to show you is a module that uses mini dump write dump, okay, to dump LSASS to disk, compress it, upload the dump to the server, and parse the dump server side for creds using a tool called PyPyCats. If you aren't familiar with PyPyCats, it's basically a Python implementation of Mimikatz that allows you to dump basically creds from a LSASS dump server side. Okay, so let's try this out. Okay, so this is I just selected the module, navigated it, all fine and dandy. So now we're going to execute it. Cross our fingers. Is it doing its thing? It's doing its thing, I think. There you go. Okay, so it dumped it. It's uploading it really slowly. But again, a new feature of Silent Trinity is you can customize the sleep interval. So all we have to do to make it faster is just tell it to go interactive, similar to Cobalt Strike. I'm going to do that now. Okay, so, and it's async too. So now, yeah, there you go. So now it's a lot faster. Yeah, there you go. So we got, and that was fast, right? And now, and there are the creds. So it's basically safety cats. It's not even executing Mimikatz, just dumping it, uploading it server side, and executing and parsing it for creds server side. Okay, and there's a lot more stuff. Like this new update, it's going to make it actually functional. So hopefully you'll be able to actually start using it on engagements. Really quickly, detection. .NET 4.8 has AMSI integration. So because of the way this works, AMSI really doesn't have a lot to go on here because you're embedding a Boolang. For example, like the PowerShell one specifically, like you're embedding the Boolang compiler within PowerShell. Every time you compile that Boolang source code, it'll generate, like there's nothing, it'll just interpret it. So there really isn't a lot that AMSI does with Boolang source code, in my opinion. So the only thing that I've seen so far is like actually signaturing on like instantiate, like the name of function name again. But like there really isn't a lot to trigger on if you just embed the source code within PowerShell itself. Okay, there's a lot of stuff that's been coming out, and this is getting better. Again, like the .NET 4.8 having AMSI integration makes this a whole lot better already. But there's a lot of ETW stuff, which is the technology that Microsoft has to basically detect a lot of this. And these are all the links to that if you want. The Krabs ETW is the official wrapper around that, but it's C++, and it's sort of like build your own tool, so to speak. So it's not exactly like the best thing to do. Silk ETW, although is awesome. Check out that project. It's pretty cool. It's an open source project, so if you're trying to detect this at scale, might not be as effective as you want, but it's something that you can definitely put on like targeted endpoints, like high value endpoints or something if this is really a concern. There's also a couple of blogs out by Countercept, which I think is an MWR company, which basically goes over like hunting for silent trinity, all that stuff. And Luke Jennings did an awesome talk about Blue Hat about this, so there's that too. And thanks for Ryan Cobb at SpectreOps actually putting a lot of these together, and I just added a couple on to that. But yeah, thanks for that. So the best way of detecting this, though, in my opinion, okay, is that. So if by inspecting the assemblies loaded in the app domain, you can see which ones have been loaded reflectively and which ones have a file backing on disk, okay? So I have yet to stumble across a legit .NET application that loads stuff from memory. I don't know if it's just me or am I not looking hard enough. So like, really, if you see anything loaded from memory that doesn't have an assembly backing on disk, that is by far like the best way, I think, right now of detecting it. And again, like in this particular case, you see like the silent trinity thing has been loaded, so you know that's a giveaway. And also IronPython, Boolang, and basically any .NET scripting language now is IOC. Like I would definitely like if you see anything loaded that's like IronPython and Boolang, that's probably very suspicious. I already did all this, so you don't have to worry about that. But the long-term goal would be to use like integrate CrackMap exec within Silent Trinity too, so you have like a tool that does like your internal stuff and everything else, C2 stuff. So that'd be good. Questions? Yes. It would defeat the PowerShell stager, probably. Yes, it would defeat it, the PowerShell stager. But again, like it's .NET, right? So PowerShell isn't the only thing that ingests and can execute an assembly. So you can embed it. You can use like .NET to JS, for example, embed it in an XSL file, execute it via WMIC, like another sub-T bypass. You can just your world's your oyster at this point. So the one I usually use is the MS Build one because that still works a lot. But I have a couple others too that I'm working on that are not quite ready yet. But if you're trying to defeat like only the PowerShell stager, constrained language mode would help, yes. Welcome. Any more? Going once, going twice? Sold. Okay, thank you for coming.